Hello, today I want to talk to you about stereoisomers, especially enantiomers and diastereomers. So we're probably familiar with the term isomerism and understand a little bit about what isomers are, but there's different kinds. We may recall what structural isomers are. Structural isomers are molecules that contain the same molecular formula but differ in connectivity. In other words, the same number of the same types of atoms but connected differently. So here's an example of two different butanes, right? We have the straight chain butane, which is right here, and isobutane. They're both C4H10, but they're connected differently. As opposed to the straight chain butane, the isobutane, one of the carbons has moved over to the middle, right? So these are structural isomers. Now stereoisomers are compounds that have the same molecular formula and the same connectivity, right? In other words, the same atoms connected in the same way, however they differ in the way they are oriented in three-dimensional space. So something like this, we can see that this is the same atoms bound in the same manner, however they differ in the way they are oriented in three-dimensional space. And I'm here to talk about why these guys differ in the way they orient in three-dimensional space. All right, so now we're going to talk about enantiomers. The first kind of stereoisomeric relationship I want to talk to you about involves molecules that are called enantiomers of one another. Enantiomers are molecules that are non-superimposable mirror images of each other. In other words, they are stereoisomers, so they have the same connectivity. If you take the mirror image of one of the compounds, you get the other, and they're not the same because they do not overlap precisely the same way in three-dimensional space. So take for analogy my hands, right? So I have one of my hands right here, and the mirror image of this hand is my other hand, right? So these have an enantiomeric relationship in the sense that they are mirror images of one another. They do not precisely overlap, meaning I'm not able to get every finger to overlap its corresponding finger properly. So they have an enantiomeric relationship because they are non-superimposable mirror images of one another. And we can come up with all kinds of different examples of this. The molecules are doing the same thing. So let's take an example of this molecule right here, right? And we're going to reflect it across the axis, right? All right, we'll reflect it across the mirror plane here. We can all agree that the mirror image is this right here. So we have X, whatever these atoms are, it doesn't really matter. And then you have the Y atom and the Z atom, and these are mirror images of one another. But now if we rotate the resulting mirror image to try to place it on top of the original, so in order to do that, if we want the X to line up, we're just going to twist this like a top 180 degrees, and we would get this. But the problem is if we try to take this and put it on top of that, then not all the atoms are going to overlap properly. So the W, the central atom, and the X, these would overlap just fine. We find that the Y would be on top of the Z, and the Z would be on top of the Y. Therefore, these molecules and its mirror images, which are two distinctly different molecules, are enantiomers of one another because they are non-superimposable mirror images of one another. So you can see, they're non-superimposable mirror images of one another, okay? Next, I'm going to talk about chirality. All right, so molecules that have an enantiomer display a quality called chirality. This is something we would typically assign a carbon that has 4 different substituents projected from it. So for example, on the top, this carbon atom has a bromine atom, the implied hydrogen, and the 2 identical methyl groups, so we would not regard this as chiral because it has 2 identical methyl groups, so it does not have 4 distinctly different substituents. Now this would mean that this does not have an enantiomer because if you made the mirror image of this molecule, it would be precisely the same molecule, it would be superimposable, so it would not have an enantiomer. Its mirror image would be identical and is therefore not chiral for the first one right here that I drew, okay? However, this molecule right here that I drew, that one is chiral because this carbon has a bromine atom, the implied hydrogen, the 1 carbon chain, and then a 2 carbons. So that is 4 distinctly different groups. And if we went and took the mirror image, we would see that it is now that. This is the mirror image that I drew right there. If we try to flip that around, we get the same structure, but now the bromine would be on the dash bond as I drew right here. I flipped it, right? Okay, because if the bromine atom is on the wedge bond out of the paper, like this, if we flip the whole thing 180, now the bromine is going into the paper. So if we try to place this on top of that molecule, it is not going to line up properly. So therefore, this molecule is chiral. It has a chiral center, or center of chirality, or a stereogentric center. All terms that mean the same thing, and therefore, it does have an enantiomer. Likewise, over here, this one I drew right here, this is a carbon with 4 different groups. So this is a similar molecule, but 2 of the groups are the same. So we have 2 fluorine atoms. So you, at home, want to go ahead and check. You can draw the mirror images of both this one right here and the mirror image of this one right here, right? And you can see that they are both chiral because there's no way to rotate its mirror image as to place it upon the original and have it line up flawlessly. However, this last one right here, which I drew, right? This one is having 2 identical fluorine atoms. So if you drew the mirror image of this molecule, there is a way that you could rotate it as to make it flawlessly superposable. Therefore, this cannot be chiral. This is achiral, and the A is a prefix that implies not. So this is not chiral. It does not have a mirror image that is distinctly different from the original. Just to double check to make sure, this one is not chiral. This is chiral with the mirror image shown. This is chiral as well. This one is not chiral. Thank you guys. I hope you enjoyed this video. I hope that it explained the topic of chirality well.